Hi, welcome to the Calculus 1 lecture series. And we are in the unit number 3, application of differentiations. And this is our lecture number 20. In this lecture, we're going to take a look how the derivatives of a function affect the shape of these functions and affect the shape of the function's graph here. So in here, we're going to talk about how do we determine that a function is increasing or decreasing, or a function is a concave up or a concave down here. And then how is the shape of the functions, and how do we have use the first derivative test and the second derivative test. So basically, we're going to take a look how do we define the shape of the functions by using the first and the second derivatives here. Okay, so now let's go ahead and go to our lecture notes here. Okay. So the first one we're going to talk about is increasing and decreasing test here. Okay, so what is the increasing and the decreasing test? So here, first things here is we say if, okay, f function is differentiable, okay, so if a function is differentiable in intervals, on an interval here, okay, and then we say here, so the f prime x greater than 0 for all the x in I in this interval, then implies the f is increasing in the I, okay? Then the same things here, if f prime x is less than for all the x in this interval I, then that means implies f is decreasing in I here, okay? So let's see here. So in here, if it's greater than 0, then it's increasing here. And then if you say this is less than 0, this is decreasing. So this is a kind of makes sense. So let me show you, let's use a graph. So maybe we can get a better idea. So here, for example, this is my graph here. And then take a look here. If I have a function like this, okay, so this is if this is my function f of x here. So remember that the derivative is is the slope of the tangent line. So if you find the tangent line along these functions here, along this function f of x, so what happened to this tangent line? Those tangent line is all climbing, it's a go, upward, right? So all those tangent line has a what? Have the positive slope, right? So because all these have a positive slope, that is why we say the first derivative is greater than 0, then my function is what? My function is increasing. So the same things here. So let's take a look at another one. So for example, if you have a function go like this, so if this is my f of x, then you do the same way. You say, okay, now I'm finding those are the tangent lines here, right? So did you see those red tangent lines all go downward, right? So this is all go downward. So what happens here? So all this here have what? Is a negative slope, right? So we know the slope of the tangent line, that's how is we define the derivative. So that is why, so if the f prime x greater than 0, then we know that f is increasing. And if f prime x less than 0, then we know f is decreasing here. Okay, so the increasing, decreasing test is pretty easy here. So you can just draw a graph and then you can see the slope of the tangent lines here. Okay, so now let's take a look here. So they said for this problem here, they say the graph of f prime here. Okay, so be very careful. So this is f prime here, right? So this is the f prime. Then they said where is increasing and where is decreasing here. Okay, so remember the increasing is f prime greater than 0, right? So here, this is where is the increasing, so it's greater than 0, right? So it's from this one is greater than 0. This one is greater than 0. Did you see here? All right, so I know the f here is increasing from where to where? From the negative infinity to negative 2. And from where? From what? 0 to where? 0 to 3. Right? Because it's f prime positive. Okay, so now where is f decreasing? Decreasing is the f prime less than 0. So I know this area is less than 0. This area is less than 0. So we can say what is f is what? F is decreasing. And where? From the negative 2 to 0. And then union 0 to what? 0 to infinity. So here. Okay, so now, right, number is f prime x. So now let's take a look at the second problem. They say, is f of x equal to x squared plus 6x increasing on this interval? All right, so in order to get increasing, I say, okay, the first thing is I need to take a look at the derivative. So the derivative here, this is 2x plus what? 2x plus 6 here. I know if it's increasing, then that means the derivative has to be what? Has to be greater than 0. So let's see this derivative. So f prime x greater than 0. So that means if you factor 2 out, is 2x plus 3 greater than 0, right? So that means what? X is greater than negative 3. All right, so that means here, negative 3, all these intervals, all this interval here will be greater than 0. So is this one is greater than 0 here? Yeah, right, because negative 1 to 2, it is greater than 3. So we say yes here. Okay. Now let's take a look at number 3 here. Number 3 is said for a given function x cubed minus 3x, where is increase, where is decrease? Okay, so right now we know I just take the first derivative. Okay, so the first derivative is 3x squared minus 6x. So the next things here, I'm going to see I'll be able to factor out something here. So this is 3x minus 2 here, right? Okay, so now because this is greater than 0, so that means I have this term and these terms, right? Okay, so the way we typical, if you like, you can. Okay, so you'll be able to kind of do a little graph. So you will set because we want to see this is greater than 0. So you set this one equal to 0, this one equal to 0. So x equal to 0 and x minus 2. X minus 2 equal to 0, x equal to 2. So here, a typical do here, this is 0, right? Here is what? Here is 0, 2 here. So this is 3x times x minus 2. Okay, so now let's take a look. So what is the, so here, okay, so take a look for everything is less than 0. So this x is less than 0, so it's negative. And this one is negative. So the overall is what? It's a positive. Okay, so let's make sure we kind of highlight that. So this is a positive. Okay, so now the next one's here. between the 0 and the 2. So you can choose any number. So if here, let me try to maybe highlight. Okay, so this negative is from x. And this negative is from x minus 2 here. So that's will make it, maybe the color coding will make it better. Okay, so now you choose anything in here, right? So from the 0 to 2, so you pick up any, like say 1. So what happened here, this is a positive. Now what happened here, this is a negative. Right now, the positive times negative, overall, you will get a what is negative. So let me also color coding here for you. So this negative is from x minus 2. And this positive is from the x here. Now overall is what? Overall is negative here. All right. Okay, now let's do the next intervals here. The next interval, this is 2. So you say choose any number. So you will have a positive for the x value. So you say 3. 3 minus 2 is so it's a positive. So it's a positive, it's positive. So let's try to color code that. So this positive is from x minus 2. And this positive is from the x. And then now what is the overall? Overall is positive, right? So I know, you know, if it's increasing, then my derivative. So this one's here, this is f prime, right? So my derivative has to be positive. So I know f is increasing where the derivative has to be positive. So it's negative infinity all the way to 0, right? And then union what? 2 to the what? 2 to the positive infinity. Then f is decreasing from where to where? This negative is from 0 to where? From 0 to 2. That's right. Okay, so let's be very careful, right? So that's why when you take the derivative of the first derivative and you factor, then you find where you break the lines here. Then for each term, you say it's negative, positive, negative, positive. Then you can see the whole interval, your derivative is positive or negative. Okay, very good. Now let's take a look at the problem number 4 here. The problem number 4, let's said, sketch a graph, you know, with all these properties here. Okay, so let's see here. All right, so the first thing is let's try to put those point on. So the F0 is 1. So that means my graph going to go through this 1. 2 to the 3, so my graph going to go through here. 5 to the 0, my graph going to go here, right? Okay, so now let's take a look at, let's say, f of prime x is, this is greater than 0, is 0 to and 5 to infinity. What's that mean? That means because this is greater than, so my function going to be increasing from the 0 to 2 and from 5 to infinity here, okay? And also then here, this one's here is less than 0 from the infinity to 0. So here is a type arrows here, so it has to be negative infinity to 0, and then the 2 to 5 here. Okay, so that means in here we have a decreasing. Okay, so let's see, we can try to put this graph together. All right. Okay, so greater than 0, from 0 to 2 is increasing. Okay, 0 to 2 increasing. Of course, the exact graph, so here is increasing. And the 5 to infinity is increasing. So sometimes go like this, is continuous increasing. Then negative infinity to 0 is decreasing. So maybe I will have some function. Okay, let me see. Let me put a better drawing here. So maybe I have some function go like this, right? So it's a decreasing to here, and then turn and increasing. And the 2 to 5 is decreasing. So I'm going to have something like that. Okay, so this is what? This is my f functions. f function here. All right. All right. Okay. So this is a pretty, so this is what we call the increasing and decreasing test. Okay. So now the next things here we're going to talk about is the first derivative test. Okay. So what is the first derivative test? The first derivative test, what's the purpose here? The first derivative test here. Okay. So they will tell us when a critical number is a relative is a relative extrema. That means it's relative max or relative means here, right? So the key points here is because it will tell us the critical number. So if you remember the critical number we defined in the previous video, is the first derivative equal to 0 or first derivative is not defined, right? Okay, so what is the first derivative test? Okay, so let's say we say suppose C is the critical number. So if the C is the critical number of a continuous function, f here, okay? And so we say if the f prime x is greater than 0 in the AC, and f prime x is less than 0 in the CB, then we said f has a local maxima at the x equal to c, right? So the same things here. So if they say that if f prime x is less than 0 in the AC, and f prime x is greater than 0, okay, in the CB, then f has a local minima at C. Okay, then the part C tell you, and so let's say if f prime x has the same sign, okay, in both AC and the CB, then we know FC is not a local extrema. Okay, so this ones here really is the kind of pretty easy to understand intuitively. So let's say suppose C is a critical number, right? So we said a critical number is where the f prime x equal to 0, right? So let's say here this is C here, and then your point is A here and the B here. Okay, so in here they say if the f prime x greater than 0, that means I know the greater than 0, we already did, we say greater than 0 is what is increasing, right? Increasing from the A to C. Then after that, f prime x started decreasing here, right? So the started decreasing here. So now this is where right? So that's why this is where it turns, right? So that's why you got a tangent line. It's the, you know, the tangent line, the slope is 0. That's why it's where is your critical points, right? So if this is the one, so well, of course, so what is this one? This is a local max here, right? Because it's the same thing. Then now the same way is here. They said if your critical values and is C, so you say if this is C, and then you say this is A, this is B. Then if it tell you, hey, if the AC is less than 0, so that means I'm going to decreasing. Then when I hit here, oh yeah, so net prime is greater than 0, I'm going to increasing. So what happens here? This one's here will be my what? Because here this is the critical point, the tangent line slope equal to 0, right? So this is the local mean here. So if they tell you if the A and the C, they both it's both increasing, decreasing, that means I'm not turning here. So it's not a local max or local mean here. All right. Okay. So now here, let's take a look at these examples here, right? So let's see what that means here. Okay. So let's say suppose a critical number for a function f for which f prime is greater than 0 for x, you know, so let's say suppose 8 is a critical number. Okay, so let's see here. So this is the 8, right? Okay, and then in here, the point A to 9, right? So this is A to 9, my f prime x greater than 0. That means what? I'm going to increase in here, right? So I'm going to increase in, then for x is 7 to 8 here. So if you here is 7 to 8, then it said is less than 0. So that means I'm going to decreasing, right, the function. So you're going to have something decreasing, and the A is a critical point. So you have to decreasing, and then boom, turn, right? So now here, this is the 8. So what is this one? It's a local what? It's a local minima here. Okay, now let's take a look at number 6 here. So the number 6 is telling you, let's say that the critical number for differentiable functions, 1, 3, 4, 6, 8. Wow, we have 5 critical numbers. Okay, so what can you conclude about the local extrema and you know, the so from these tables here, right? So let's do this. Okay, so you can do here, let's see here. So if a -1, negative infinity is a positive, so what is here? This is increasing. 1 to 3 is a what? Is decreasing, right? It's a negative decreasing again. 4 to 6 is increasing, increasing, decreasing. Okay, so now let's try to take a look. Where is my extremas here? Put it into a number lines here. Okay, this is my 1, 3, 4, 6, 8, right? So this is my critical numbers here. Okay, so now we say negative infinity to 1, so it's increasing, so it's go like this, go up. Then 1 to 3 is a decrease, negative, so it's go down. And then 3 to 4 is another going down, right? Then 4 to 6 is positive, so it's increasing. And the 6 to 8 is a continue increasing. And the 8 to infinity, so it's decreasing. Okay, so now let's see where is the turning points here. Okay, so this is increasing, boom, decreasing. So here is a turning point, right? So what is this turning point? So this is what? Okay, so this is local what? Max, right? So local max f x, this one's here. So this is a turning point, x equal to 1. Okay, after it's a turning point, then it's going down. Oh, this nothing's continue going down, right? Okay, so now like for this one's here, I say, oh, okay, after you're going down, boom, it's coming up. So here is my another turning point here. So what is that turning point? That is my local minima, x equal to 4. Okay, now let's take a look again. So it's going up, oh, boom, going down again. All right, so I know this is a up and a down, so I have another turning points here. So this is 8. Okay, good. So I have a local max and x equal to 1 and 8, right? And the local mean is x equal to 4. Now we still have no local extrema at where x equal to 3, right? So for 3 here, it's just continue going down, and x equal to what? X equal to 6, and just continue going up, right? So there's no turning points here. All right. So now the next thing is here. They said find where is the local maxima and the minima value for these functions here. So this is just kind of similar like we did the increasing and the decreasing test, right? Okay, so the first thing is here, you say f prime x here. Let's take the derivative. So it's 12x squared minus 4x what? 4x cubed, right? Like we said, let's try to factor. So it's a factor 4. I can tell the x squared, and then this is the 3 minus x, correct? So this is 3 minus x, and then we say we set this term equal to 0, and we set this term equal to 0, right? Okay, so if this term equal to 0, this term equal to 0, what I have, x equal to 0, x equal to 3. Okay, so now let's do the same way. So we plug it. So this is 0, this is 3, right? Okay, so now let's see here. Okay, so for anything less than 0, so like -1 here, but this is x squared. So what is here? This is a positive. If this is -1, 3 minus -1, what is here? So this is what is a positive, right? So if I want to make it a highlight here, so this is a positive, and this one is a positive. So what is overall? Overall is a positive, right? Okay, so it's a positive. Okay, now let's take a look at this ones here. For everything between 0 and 3, so this is a positive. You choose, for example, you choose 1. Okay, so between 0 and 3, what happened here? You choose 1. 3 minus 1 is 2, it's a positive. Okay, so good, right? So this one's here is a positive from the 3 minus x, and this is a positive from the x squared. So what is here? Positive is a positive. Okay, now let's take a look. Greater than 3. So if you choose 4, 4 to the square still is a positive. How about the 4? 3 minus 4, this will be negatives, right? So here, this one is from the x squared, and this one is from 3 minus x. Okay, so what you have here, you have negatives, right? So this is your f prime x. Okay, so now we can do a graph here right now. Positive, so what is a positive? Increasing. And the positive is increasing, all right? Positive and the positive is increasing, so here. And then this is negative, right? Negative is what is decreasing. Okay, so it's decreasing. And then now you will see, oh, here got a what? Here got a turning points here. Okay, so what is the 3 here? So this is increasing, decreasing. So x equal to 3 is what? This will be a what here? This will be a local max here, right? How about for this critical point, x equal to 0? So what happened to x equal to 0 here? So we say x equal to 0. So we don't have no local extrema, right? It's because it's continuing increasing so here. Okay, now Okay, let's take a look at a few more examples and then we should be very good at this. Okay, so now the next one is here. They say find the local maxima and the minimum value for the f of x equal to the x plus sine x. Okay, let's take a look at the f prime x here. Okay, so the f prime x will be just 1 plus cosine x here. Okay, now you say 1 plus cosine x, so you immediately recognize the cosine x is always between -1 and 1. Am I right? Okay, so you plus 1 plus cosine x will be always less than 2 and greater than what? Greater than 0. See here, this is, so I know, so this one's here, the 1 plus the cosine x, this is my f of x. So the f of x is always continuous, right? So there is a what? So this is this function is always continuous, right? I'm sorry, it's always continuous, always going up, right? So always increasing. And because it's continuing increasing, so there's no turning point. So what happens here? So we say there's no local extreme values, right? So we don't have local extreme values here because this is a continuous increasing point, increasing function. Okay, so last example, let's take a look at the graphing again, all right? So this graph, the graph here will really maybe help you to get the get a better understanding. Now we add a little bit more conditions here. So let's try to mark the point, right? So the S0 equal to 2, all right? So let's say here, 0 equal to 2. Maybe put it in here, okay? So let's mark it a little bit. So this is 1, 2, 3, 4, 5, something like that, all right? So this is 0 equal to 2, 3 equal to 1. So this will be my another point here. And 4 is equal to 0 here, okay? Then they say I have vertical asymptote. Okay, vertical asymptote. That means here, this is my asymptotes here, right? This is x equal to 2. Okay, so now let's take a look at the decreasing part, right? So decreasing part, f prime x less than 0, when x is less than 0. So this is decreasing, and then x greater than 3, this is decreasing here, right? So the both of them here, this is decreasing and this is decreasing here, okay? And because this is a asymptotes here, so from the 0 to 2 is greater than 0. So greater than 0 here, greater than 0 here. What does that mean? That means those are increasing here. Okay, so let's try to graph it. For x is less than 0, right? So I know from less than 0, so it's decreasing. So I'm going to have some function go like this. All right, let me try to get a different color. All right, so here, let's say here, right? So it's decreasing, right? So from here, so I would say here is, right? So it's decreasing here. And then from 0 to 2 is increasing, so I know it's going to turn, right? So it says continue increasing, right? So that means then here's the asymptote. So I know my function probably will go like this, right? So it's kind of increasing, and getting to the what? Getting to my asymptotes here. Whoa, that's a terrible drawing here. So let me see here. So okay, so make sure I draw good. So it's kind of like a, right, go like that. And then after 2 to 3 is also increasing, but here's another asymptote, so I know this is my functions here, right? So from here is go increasing here. After the 2, after the 3, then what happened? I'm going to decreasing here, right? So I continue decreasing. So that's why my function going to be like this, continue decreasing here, right? So that is what happened to my graph here. So, and so after you know the graph, the first derivative test, right? So you can see where is the critical values and the functions increasing and decreasing behaviors here. All right, so that's it. Let's take a break here. Then in our second part, we're going to take a look at the concavity. Okay, that's it. Okay, so talk to you later on our second videos here. Okay, bye.